My name is Thomas Gunkel. I'm working for a company called Skyline Communications. Very briefly, for those who don't know who we are, we do only one product, which is called Data Miner, which is in essence a monitoring and orchestration software for the ICT, media and broadband customers. We are present around the globe in more than 100 countries, have about 10,000 nodes deployed, and we integrate with many different products and platforms, about 8,000 different ones from many thousand different vendors. Very briefly on cloud adoption in media and broadcast. I guess that's nothing new to most of everybody. Why going to the cloud? It's mostly for scalability, to find a flexible solution or to be able to stay flexible. Also about security, reliably and being cost effective. But when you look more into media and broadcast, there are specific use cases. One of them is really virtualized productions, remote productions, which goes along with the complete transition from SDI to IP. Another big topic when we talk to our customers is mostly the war of talent that allows you, when you go to cloud, that you can bring people together from all over the globe and working together on one single production or as a team, but doesn't really matter that you have to be in the same room still. For the companies being available or working globally, that's also a big important topic, to have cloud-based systems available globally, that you don't have to move and ship your equipment around anymore. And moreover, when we talk to the billing and costing people, you can nowadays do the billing, the costing activity-based, means per production, whereas in the past it was more costing a one-time off to build a new production studio, and then costing was always a bit of a challenge. Now it can be much more granular. What we see, and that's an important one, that going to the cloud comes with a completely different set of challenges than it was ever before. We call it digital transformation. When you look into how people did projects in the past, which was much more a waterfall project, you were planning, you were installing for a couple of months or even years, then you operate for several years and then you replace it again. That doesn't work anymore. Digital transformation is really about being capable of dealing with changes easily, efficiently, and changes can come from many, many different angles. Those are changes in technology, also people, methodologies. You need to come up with a different approach when you run a cloud-based project. And that's much more towards a DevOps style, an agile environment. You might have heard those terms, the ICDCO, where you constantly need to create, operate, evolve in small iterations. And that not only affects technology, that's really the whole operation, companies that need to transform the way of working into being a more digital company and a software-driven organization. Now, going further to the cloud, what is a production in the cloud? What does it mean? It's not only that you start and stop a production, or you walk into a studio and turn the lights on and off you go. There's a complete life cycle to it. It starts with planning. Planning was usually done also for your on-prem productions. That's nothing new, but you need to stitch things together. There are different teams involved in such a life cycle. You have administrative data that gets gradually collected. Then you need to have transitions between those steps that need to be managed. When you hand over from one team to another, is not the best way to send an Excel sheet. That needs to also be digitized. You need to orchestrate resources for sure. Before you can use resources in the cloud, you need to schedule them, you need to spin them up, but also don't forget about people, on-prem equipment, which is still there, that everything needs to be orchestrated, needs to be up and running. And when you look in such a life cycle, there is a combination of manual and automated steps. A manual step can be, I need an approval process. I cannot just automate everything. There must be a manager who needs to approve maybe spinning up of an instance in the cloud or of a production. And then you also want to automate things that don't need approval, that can be automated, like my resource reservation. What we say, those productions, they're much more variable than they were ever before. They need to vary and evolve over time. Often that's not only reconfiguring resources, it's really about redeploying infrastructure, which is a completely different ballgame comparing that to on-prem productions. Bit of pitfalls. People might forget about that, but there is no guarantee that cloud resources are always available. We see that more and more for some cloud resources that need specific needs, GPU accelerated resources, etc. You can have those available in one region, you move to another region, it's just not available. You need to plan things up front and make reservations up front, also together with the cloud providers. Simple things like when the production is over, the staff just goes home, they forget to turn cloud instances off. And sometimes they don't know which cloud instance to turn off because you have multiple groups working together. If you log in into an AWS console, there's a high risk that you might turn things off that you should not turn off because there is still an ongoing production from your colleagues. APIs, they are much more complex than they were before with regular integrations on more a device layer, and they're constantly changing. So that's one of those examples that when you have an API today towards a cloud-based environment, very likely in 2 weeks, that will be a different one or will change. You have different standards again. They might be proprietary to some cloud providers. One of them is the CDI. This is from AWS, where you can put uncompressed streams to the cloud, which works perfectly well with AWS, but if you go to another cloud provider, you have to think about what you do if there is an alternative for it. Lack of multicast support, lack of PTP support, things you use on a daily basis in your on-prem productions, they're not there yet. Sometimes it's just the ease of access. It's not that easy to access your cloud instances, your cloud systems. Control interfaces in cloud systems, you have more things you can do, therefore they're also a bit more complex. And when you use a lot of those media services provided by the cloud providers, you might be locked to a single cloud provider again. That's also something you don't want to have necessarily. And when you look into a complete chain, there is always some equipment you have on-prem, but when you look into cloud management tools, there is no support for on-prem equipment. They work really good on managing cloud equipment, but no support for on-prem equipment. That needs to go together. And also what we see is what we call here the lack of confidence. It's really the trust that you have to have in those systems when you run a production that things will be spinning up, things will be there. It's just a different way of working. When you don't see your infrastructure, it's a different mindset. You need to deal with that to get that confidence that things can go and will be up and running at the right time. So what we did now about the use case, we started working with Grass Valley a couple of months back on the Grass Valley M system, have also integrated with other cloud providers. One of those examples is RTS. It's an intercom company where they do software-based intercom panels. Data Miner was there to orchestrate the resources, to add automation to spin up and down those applications, to load the right profiles, make the connectivity, do the monitoring when everything is up and running. After that, reporting is important to apply the right costs and also to cost prediction when it comes to cloud providers with dynamic costing models. How is it done? How did we do that? It's based on our data miner architecture, which is natively CI/CD, CO capable. And one of those things I want to show you is what we call object modeling in service templates. What is object modeling? In object modeling, you manage the administrative data, a bit like your Excel sheet, but more flexible. You define a data model for a production. What do you need? As a minimum, maybe a job name, an event name, start and stop time. Optional fields could be customer contracts, venues, etc. That's something the customers define on their own because every customer uses something slightly different. And then that's important, you need to link that with what I call service template. What is it that I need when I run a certain production? We store that information in a service template. And the service template includes then all the resources, everything you might want to have for that production that a system like Data Miner knows. Which services, which resources do I have to spin up at which time? When we look into that modeling here in the object modeling, the big difference compared to standard databases is that this is state aware. State aware is important because a life cycle of a production is not something that only has a start and stop time and there's just only 2 states. There's many things you do. When you look from left to right on one of those examples here, there might be a state which is called draft. It's just an example. Draft means somebody has entered data. There is a person entering administrative data, my start time, my stop time, production data. Then there might be an approval process required. That's still a manual task. Somebody has to click a few buttons to approve what people have entered in the scheduling team. Later on, there might automation be kicking in because when it's confirmed, There might be an automation script running to deploy the right instances at the right time. They need to be up and running before the production starts. When the instances or the infrastructure is up and running, you need to configure, you need to connect the resources. Then you have a running state. Then you turn things off again when the production is over. So many states going together, and important to know the way we designed it. After each and every state, you can run automation or you can do activities. And that's how you really can stitch things together with automation, but also what we say guided workflows or guided user interfaces, that people know what to do next, that they don't get lost in that complete life cycle. So everything needs to be digitized. When we look into service templates, this is really to manage the resources. We have linked now one production with one of those service templates, and in a service template you have the building blocks, and here's a very simple example that I say I might need a couple of JPEG XS converters on-prem. That needs to be connected with my vision mixer, with my streaming output multi-views. I need a few clip players. I need intercom panels, and you see there is also one of those building blocks called video operator, technical director, producer. People are also resources. And what we do here, we only specify functions, connectivity and dependencies, but we do not map them yet to any underlying infrastructure. First of all, the way we work, to be vendor independent, you define this in a very generic way. Only after that, once we know which infrastructure the customers are using, we map those building blocks to the underlying infrastructure. That can be now on-prem resources. Our JPEG XS converter can be something in a cloud. GVM, in our example, was running in a private cloud. The RTS panels were running in an AWS cloud, in an EC2 instance. And also our virtual resources, which are humans, they will be booked and reserved. And then we need to link those function blocks to the actual resources, apply then profiles, configure them. That's what a profile is. And how to do that technically, we have like a mediation layer in between, because you might have JPEG XS converters from two different brands. You might want to set the very same parameter, but underneath you need to translate this in the right API call. That's a bit the technical setup. Now, spinning up resources, what is it that we need to do? It's different things. In on-prem resources, they were available 24/7. Now, software-based needs a different approach, because the resources, that's important, they don't exist at the time of the reservation. They're just not there. You cannot only configure them, you need to spin them up or bring them up, first of all, deploy them. And we call them contributing resources. For example, in our RTS system example, the intercom panels, you need to spin up an AWS instance first. After that, you can bring up the V-Link intercom panels. Grass Valley AMP, you didn't have to spin up an EC2 instance, but you still need to spin up the applications. And even on hardware-based environments, you need to reconfigure probably an FPGA. Here we had two examples from Lavo, from EVS, in that POC or in that demonstrator. And one day, one of those boards could be a JPEG XS converted, the other day maybe an H.264 encoder decoder. That needs to also be reconfigured. That might take a few minutes. And only when the infrastructure is there, then you can start configuring the actual production resource. And there are dependencies. Now going back to, was this on the right one? Yeah. Now going back to the actual administrative data and the workflow again. It might seem to be pretty easy, it's straightforward. You have draft, you have approval, confirmed, it's in running, it's completed. But when you look into the details, an approval workflow is much more than just a single button. There's again different states. You might have received data, there might be a complete state, you might have to edit data again, might be validated, might be pending, might be rejected. That's also something you need to map out in that digital workflow to have a system that allows you to go left and right and also work on the exceptional cases that can happen, that you make sure you don't get stuck in the process, because the process doesn't really help you when you could end up in a dead end, then it would everything would stop. A system, what we did with Data Miner, really needs to support all those potential workflows that can happen, or potential things that can happen during an approval workflow. Another example here, when it's between confirmed and running, when we reserve the resources, before we then spin them down again or turn them off. You have different states within those states. So it's much more again than just two simple states between confirmed and running. A production state can be confirmed, but also can be partial. Partial means some equipment is already up and running, some other equipment still got spinned up, or maybe there is some equipment broken, so not everything is available. Can also go in quarantine. Quarantine is always a state when things go really wrong. When all of a sudden during the production you have a failure, there is a quarantine state. You need to do something about it. And then you have that service state, which is running, can be paused. Paused sometimes is used for contribution feeds where you want to save some money, especially when it's satellite contribution, that you don't run all the resources 24/7 or for your show. You can also pause them. This was really just a little bit of an introduction, how it works underneath. When we look into the operations, that's what I want to show you for the next couple of minutes. What we did there is a so-called approach with low-code applications. We see a trend in the industry, and not only in the media industry, that people need different interfaces for whatever they want to do. In the past it was more like it's the same interface for one product, no matter if you're an engineer, if you're an operator, if you're a finance guy, there was only one interface. Now those interfaces, they're much more tailored to specific needs and also much more dynamic. And instead of us as a company creating 500 different user interfaces, which would not be possible, we try to empower the end customer to build their own interfaces. And as it's natural that not every customer has hardcore coding people available all the time, which was required in the past, we went for an approach to say, let's build low-code applications. Those applications, they are web-based, and there is a user interface available that you don't have to be a developer to build your own application. This is a lot of drag and drop. You need to do a bit of scripting probably, but people like me, not having a developer background, there you can build your own app. And there we help the customers building their own applications, making them much more dynamic. A few examples. We say it's always the right interface for the right team. There is one screenshot here where you manage administrative data. That's maybe in the draft state that you need when you have a draft. You just enter the admin data, you define your forms. That's part of that object modeling. You enter, gather administrative data. There is a guided workflow that you have mandatory fields, that you have optional fields, that you always see only those buttons that you should click on to move to the next step. Then you hand over maybe to another team. And that can be, okay, that works. That can be the MCR team or the NOC team, where you need an overview of the schedules. And this is just another example and a bit of monitoring to see if for a certain production, which is here in green, it's a bit too small to see, which is running, everything works, if the RTS instances have been spinning up successfully, if the Grass Valley instances are up and running. So it's a mix of, let's see what's ongoing right now, let's see what's already finished, let's see what's upcoming, to get a good overview of your scheduling status, the resource states. And not to forget, this was an important finding also from the customers we were talking with, to provide dynamic links to the operational user interfaces. Because how would an operator know where to go and where to click? He sits in front of his laptop, he's probably working from home, and you need to tell him what to do next, because there was no UI half an hour ago, and now the UI just popped up. They need a link. Instead of calling them, sending them an email, you need to stitch things together, providing those links dynamically. When the production is over, those links will disappear, and also his user interfaces will disappear. And then you certainly have the operational interfaces, and again, just a few examples. Very often, we embed third-party interfaces. In the middle you see a GVMP interface, that is the mission mixer we were spinning up. Let's reuse that, we embed it in the framework. There is no need to reinvent the wheel. This is what the operator needs. On the left-hand side there was a specific need to be able to change a multi-viewer layout, reload a couple of clips. That user interface didn't exist natively by GVMP, so we built a quick control interface, a quick dashboard. Or on the right-hand side we see something from RTS, just a small one with our two buttons where we said, let's assign a party line for that production. And you also see, that's important, certain names. Why do you see names? Because we manage resources, we manage people. When we spin up a intercom panel, instead of saying this is cameraman or operator 1, 2, 3, just assign the right name to the right button, makes it a bit easier to handle. One last example I want to give, how to evolve, how to move things on. Certainly on the backbone, when we talk about the object modeling and the service templates, there you need more the engineering people working on those, changing, for example, automation scripts, but it's all in a CI/CD pipeline that they can constantly test and automate and evolve. But also on the graphic layer, you see here a screenshot which shows the edit mode of one of those applications. There is not a single line of code you will see. It's mostly drag and drop. You put your components in. That can be a scheduling component, a calendar component, or any other state components to monitor your equipment and to see the status. And you put together then your new version of your user interface. What's important is versioning in that case. You need to try it out. You need to test it with a few people. You can publish it, deploy it to maybe a few operators to test things out. You can also go back. That's all embedded in that approach when you say, I go CI/CD. It's really important to say we need to constantly evolve, because what we also know, you cannot define that anymore in a tender or on paper with a couple of specs. People really want to try it out, get things going, have an MVP, and then evolve over time. In the past, it was more like we had to do all the work. Now we try to make it much simpler for the operators, for the users to do this on their own. Because at the end, they know best what they want. Those are like their own best customers, and if they can do it, avoids a lot of trouble and misunderstandings and a lot of iterations. Because if somebody talks to me, explaining me what he needs, quite likely I'm not fully understanding what that is, and at the end it might go wrong, and it takes a much longer than when people can do things on their own. And in summary, how to run productions in the cloud. Yes, it's a technical challenge. You need to glue things together, but that's only one part of that make a cloud production project or a digital transformation project successful. You need to have technology, but also you need to have people. It's really a change of mindset. A lot of our customers underestimate that a bit. You cannot just deploy new technology and say this is what you work with. Coming from a more waterfall-based approach of working, and this is how we are all used to really into an agile mode. This is constant training. You need to educate your people. You need to take it very serious as a company to make this a success. And that includes the methodology. Agile principles is not just something where you can send people on a training. We did it internally and with our own company 4 or 5 years back. This was a process that took us like 2 years, and it never stops. That's constantly ongoing. That's not something you do in a year. And you need to invest time, you need to invest money. But I guess that's the only option to run those much more dynamic projects that we now see in our industry and many other industries. And going to the cloud is really just one example. There are many other examples. But I really want to say it's more than technology. That's important. Technology can be solved, but think about people, think about methodologies. It's a big thing, not just a small technology project anymore. And with that, I think I'm almost at the end. Didn't talk too long.
You did great.
Yes, thanks very much.
Thank you, Thomas.
Happy that people stayed